Hello everyone, welcome to today's session on case study application of numerical solutions of ordinary differential equations in civil engineering. I am Mr. P.M. Chellapandi from the Department of Mathematics working in SNS College of Technology, Coimbatore. Today, we are going to understand how numerical methods are used to solve real world engineering problems. We often learn mathematical equations in classrooms, but many students wonder where these concepts are actually used in practical life, right? So, in this session, we will explore how ordinary differential equations called ODEs are applied in civil engineering and how numerical techniques can help engineers to make practical design decisions, right? So let us begin. um, what are ODEs and why do they matter? First, let us understand what ODEs are and why they are important. Ordinary differential equations describe rate of change acquiring in physical systems, right? Think about a few examples. The water level inside a tank changes continuously. The movement of vehicles on roads changes with time. The vibration of buildings changes during earthquakes. So whenever something changes continuously with respect to time or another variable, differential equations can model that behavior, right? So however, solving these equations analytically becomes difficult for complex systems. Therefore, engineers use numerical methods such as Euler method, Runge-Kutta method, Milne's method, and Taylor series method. So these methods helps engineer obtain approximate solutions efficiently, right? Why numerical methods? That is my question. Now, the first session is complex geometries. So many civil engineering structures such as bridges, tunnels, dams, and buildings have irregular shapes, right? Such structures cannot always be solved using simple mathematical formulas. The second reason is time dependent behavior. Loads, water flow, traffic movement, and settlements continuously change over time. The third reason is faster solution. Modern computer systems use numerical methods to obtain quick results. So the final reason is behind accuracy. Numerical methods repeatedly improve calculations and provide reliable solutions. Therefore, these methods play an important role in engineering design. Application, let us discuss application, that is water distribution systems. Now, water supply is very important part of civil engineering. Engineers need to ensure that water reaches houses, industries, and public facilities efficiently. So differential equation help calculate flow rates and water movement through pipelines. Using numerical methods, engineers can predict water tank levels, design pipe networks, and predict water shortages. This helps create efficient water management systems, right? The next application is structural vibration analysis. Structures such as buildings and bridges experience vibrations because of external forces like wind, traffic, loads, and earthquakes. To study these vibrations, engineers consider three important factors. The first one is mass, that is represented by M. The second one is damping, represented by C. The third one is stiffness, represented by K. So numerical methods helps engineers to predict displacement and stress over time. So these predictions are extremely useful for earthquake resistant design and resistant design and bridge analysis. Application 3 is soil settlement prediction. Soil settlement prediction. Now let us discuss soil settlement prediction. So whenever a building or structure is constructed, the soil underneath experience is compression, right? So as the soil compresses, settlement occurs. If settlement is not estimated correctly, it can lead to foundation failure and structural damage. So differential equation helps model soil behavior mathematically. So numerical methods then help estimate settlements over time. This improves the safety and reliability of structures. Let us come to application 4 and 5, that is traffic flow analysis. The first one is traffic flow analysis. Traffic conditions continuously changes due to vehicle movement. Numerical methods help engineers in signal optimization, highway design, and urban planning. The next application is groundwater flow and hydrology. That is so here water movement flow, its surface plays a major role in environmental engineering. So numerical methods help to analyze water table variations, seepage through dams, then rainfall runoff relationship, and flood management. So these applications help engineers to manage water resources efficiently, and water tank drainage using Euler method. So suppose we have a water tank filled with water. As water flows out through an outlet, the water level gradually decreases with the time. So our objective is to predict how much water remains after certain time intervals. These problems can be represented using the first order differential equations. To solve this problem, we apply Euler's method. In Euler's method, we use the current water level, and we will calculate its rate of change. Then we estimate the next water level. By repeating this process, we obtain approximate water levels for future time intervals. This helps engineers monitor water systems and avoid shortages. So the key takeaway. Now let us summarize today's discussion. Numerical solutions of ordinary differential equations are used in water systems, structural dynamics, soil mechanics, transportation systems, and hydrology. So these techniques transform complex engineering problems into practical and computable solutions, right? So let us conclude this session. Numerical methods are powerful tools used by engineers to solve problems where exact mathematical solutions become difficult. So methods such as Euler, Runge-Kutta, Milne's, and Taylor series help to convert mathematical models into real engineering decisions. To understand these concepts, understanding these concepts helps students to connect theory with the practical applications. So thank you everyone for listening. I hope this session helped you to understand the application of numerical solutions of ordinary differential equations in civil engineering. So thank you so much. I will meet you with a different concept in the next video. Thank you.